It's like this. Salts is a continuation of acid and bases. So there are these things out here that you need to know. There is something in the first few chapters you need to talk about. I mean, you need to refresh, which is the preparation and separation. Okay, the separation and purification of salts. Like those uh techniques like crystallization,
Titration,
crystallization,
titration,
filtration, dissolving, all this you have to be able to recall.
titration.
Yes, that too. But titration is new. Okay. So
That's sodium, potassium, and ammonia.
uh, all those. Okay. So titration, okay, those you is later on, but you have the very basic ones, which is the dissolving, crystallization, filtration. That one you must know. Yeah.
The separation techniques.
Yeah. So that one. Then, so you have the salt definition. So, salts are ionic compound. You know what ionic compounds are. Then you know what cations are, what anions are. So cation means it's positive ions. And then anions are negative ions. So how they are formed is a bunch of words down here. They say you have a metallic ion and or an ammonium ion replace one or more hydrogen of an acid. Yeah. So what it means is like this, you have the base and then you have the acid here. So in your acid, there is hydrogen, this hydrogen ion. So the metal ion from here, where the reaction takes place, this zinc ion will replace the hydrogen ion here. So it replaces this one. So what happens is it kicks out the hydrogen and then the zinc goes in and forms this. Then the hydrogen will then recombine with the other parts, other reactants, like other ions like this to form water. So the metal ions goes in, replace the hydrogen, then you'll get a salt here, like that. So in this case, zinc replaces two hydrogen ions in the acid. So then, so I go to the salt directly, and you will see that this is the positive ions in the ionic compound of the salt. Yeah, the salt. Then this is the negative part. So you see that the positive part comes from the hydroxide, the zinc hydroxide. That means it comes from the base, it comes from the carbonate, or it comes from a metal. Then the negative ions always come from the acid. The emphasis is given because later on preparation of salts, we have to talk about it again. So positive come from the base, metal, and carbonate, and then the negative one come from the acid. So there's this thing called water of crystallization. So when salts are formed, they there are two types of salt. One is hydrated salt and one is anhydrous salt. So when your salt ions, right, combine with water molecules here, they will get all these water molecules are called water crystallization. Then when you have water crystallization amongst the ions, the salt ions, then you'll get a hydrated salt. If you don't, then it's at a hydrosol. So you have copper sulfate. Copper sulfate is present in the hydrated form and the anhydrous form. So they have different appearances. So this one appears as crystal form and this one appears as powder form.
The hydrated copper sulfate, the formula is CuSO4 plus H2O.
CuSO4 dot something H2O, XH2O. X, I don't know what's the number right now. So different crystals will have different amount of water crystallization. So when copper sulfate loses its water crystallization, then it will become the white powder. Then when it's like this, right, then its formula will be just like that. So there are experiments to show you that this process is reversible. Say like you can add water to anhydrous copper sulfate, then it will become blue again. So it has become a test for water using anhydrous copper sulfate. But I didn't think it's in syllabus, so just additional info. So to prove that people made this experiment, did this experiment. So they have copper sulfate and then they heat it. So when they heat it, right, the water of crystallization will be driven off. We get rid of the water crystallization. So when the water disappears, then it becomes white. So there's such a thing called water crystallization in crystals. So there is this thing that you need to know. I mentioned it during our first lesson, I think. So there are a bunch of salts that are soluble and the rest are not. Most of the salts are soluble because they're ionic compounds. So the ones that are not soluble, they're all exceptions. They're exceptions. So your spent sodium, potassium, ammonium, and nitrates, these are all soluble salts. So you can have sodium carbonate, you can have sodium nitrate, you can have sodium sulfate, you can have sodium chloride. They're all soluble because it's a sodium salt. Same goes for nitrates. You can have lead nitrate, it will be soluble.
Magnesium nitrate.
All soluble.
Magnesium nitrate.
Yes, any nitrate is soluble. Then chlorides, right? Most chlorides are soluble except for that two that's mentioned down there. There are more that are insoluble, but it's not within your syllabus, so we shall just ignore them. Therefore, sulfates is the same. You have calcium, barium, and lead sulfate that are insoluble. And lastly, you have carbonates. All carbonates are insoluble except for sodium, potassium, and ammonium carbonate. So this table is a must know because later on, if you don't know this, you don't know how to do preparation of salts. So there are techniques down here. We need to do a recall. You have to recall what filtration is. You have to recall what evaporation and crystallization is.
Filtration is the separation of a mixture of a solid and a liquid.
So filtration will be something like this.
and liquid.
So you have a mixture of solid and liquid, like you say. Then you have a filter funnel stashed with filter paper. Then you have a conical flask. Then you just put the funnel on into the conical flask. Then you pour whatever that is your mixture, and then you just pour it here. The solid will be trapped here, and the liquid, which is the filtrate, will be here. Like that. So you have evaporation. So evaporation, what you do is you separate water from maybe a salt. And then this salt must be stable to heat. Stable to heat means it does not decompose on heating. What you do is you will heat it here, and then the water will evaporate. Then at the end of the process, you will have all the salt powder at the bottom. Then you just take a spatula and scrape out all the salt, and then you can collect it like that. That is evaporation. So crystallization starts from, actually crystallization starts from this step. Step 2. Assuming you already have a solution. You already have a solution. So you take the solution and you evaporate it until maybe say you are left with like half of the solution, where they might call this point where the solution becomes saturated. Okay, so when it's saturated, you take it out from the flame and then you allow it to cool. Once it cools, right, the salts will just, the salt crystals will appear, and you can just scrape it out, put on filter paper and dry it. That's crystallization. This is usually for salts that, okay, salts where you want crystal form, you want crystals, and the salt will decompose if you heat it strongly. So this is when you use crystallization. So these three methods will be heavily used in whatever you do later on for your salt preparation. So salt preparation, you have 1, 2, 3, 4, 5 methods. So you told me about titration, which is the first one. Then you have acid plus bases, where this is insoluble. And then this is insoluble. And the metal is obviously a solid. Then the last part is precipitation. The method 1 to 4 is used to prepare soluble salts, and method 5 is for insoluble salts. Okay. Okay. Then then the whatever steps you have just now from the recall is all here. Dissolving, filtering, concentrating, and crystallizing. So if you have those questions where you have excess insoluble base, insoluble carbonate, insoluble and metals, right? This is the usual method to obtain the soluble soap. So what you do is you have the acid, then you have the base, the insoluble base, insoluble carbonate, and metal. You just throw inside. You just throw it in. And you put a lot of it. You use excess. Then you keep stirring until no more solid dissolves. Then you will put that mixture through a filter funnel with filter paper. So which is the method just now we talked about. Then the excess solid that you introduce here will be caught on the filter paper. And the liquid salt, the solution, the salt solution will flow through and then collect here. So what you do is you take this and then you heat it until it becomes saturated. Evaporate until you have a saturated solution. So once you have a saturated solution, you take it out and then you just leave it there and wait for the sugar, the salt crystals to appear. So you see that this method here, right, the step last here, this step and this step appears very often in salt preparation. You must be able to describe the steps. That's the thing. So I'm describing all the methods you can use. Then after that, then we start, then we will apply all the knowledge of this and see what method, so what methods to use for what compound. So you have titration, which is your method 1. What is titration again? We were talking about it a lot just now. So titration is used to prepare soluble salts. And you react acid and alkali. Sometimes you can use soluble carbonates as well. Sometimes you use soluble carbonates too. So it's divided into 2 stages. You do titration. Then after that, you repeat the whole titration without the indicator. So the example that is given, right, is to prepare potassium nitrate from potassium hydroxide and nitric acid. So drawing is here. So you need to know the apparatus name. So this is a pipette and this is a burette.
Then need to use the pipette filler.
So yeah, so you take a pipette and then you take the base or the alkali, you say. So you collect 25 cm cube of the potassium hydroxide. Then you throw it into the conical flask here. Then you will drop a few drops of indicator inside here. So in this case, they use methyl orange. Then what you do is you will fill the burette with nitric acid. And it looks like that. Then you take whatever you have here, put under the burette. Then you will slowly pour the nitric acid inside here. Then you will stop when the solution just change color and it change to orange. Then you record the reading. Say once you record the reading, you will see that maybe say 23.5 cm cube is used in the burette. Okay. So maybe like that. Then after that, right, you will repeat the whole experiment again, whole process here again. Then now you don't use methyl orange. So you will repeat, take out 25 cm cube again, and then fill up, pour 23.5 cm cube of acid into the potassium hydroxide. Then you will get your salt solution. So that was this. Then you prepare 25 cm cube of potassium hydroxide into beaker again. Then after that, use in pour 23.5 of your nitric acid inside. So then from here you get a salt solution. So this salt solution, you will heat it up. Then you evaporate the water to form a saturated solution, which is whatever you saw earlier. Then you will allow it to cool to room temperature, so it will crystallize. You will then filter the solution to obtain crystals. Like that. Then after that, then you dry the crystals by pressing between a few pieces of filter paper. That is titration. They will expect you to write all the steps if they ask you to describe. Okay. So, okay. So I have one question for you. So what is the name of the salt that is produced in this titration again?
Potassium nitrate.
Okay. So what if I want to produce ammonium chloride using titration method?
Hydrochloric acid.
So what should I use?
Hydrochloric acid.
Okay. So I'll change hydrochloric acid into which apparatus?
In the burette.
So hydrochloric acid here.
Ammonium hydroxide. In the pipette.
Ammonium hydroxide. Then
Put the pipette with 25 cm cube of ammonium hydroxide into a conical glass.
yes, then
Add 2 drops of indicator to the ammonium hydroxide.
yes, good.
Then add hydrochloric acid slowly from the burette until the solution just turns orange.
Okay. Come on. Record the volume of hydrochloric
Record
acid
the volume
used.
of hydrochloric acid used.
Then after that,
Then repeat it without the indicator.
Then some more. Any more?
The solution to evaporate water
Yeah.
from the saturated solution.
So in this case, you will write from the ammonium chloride solution. Then allow the hot solution to cool at room temperature so that ammonium chloride crystals can crystallize. Then filter the solution to obtain the ammonium chloride crystals. Then rinse with distilled water. Then you are done. Something like that. So method 2, you will have acid and insoluble base. So what they have down here is the preparation of copper 2 sulfate. Copper 2 sulfate. Yeah. Formation of copper 2 sulfate. What you start with is sulfuric acid and copper oxide. Sulfuric acid here, and then copper oxide. So this is easy. You have a fixed amount of sulfuric acid. Then you will pour copper oxide inside and you pour excess copper oxide. So you pour, then you will have a mixture of copper sulfate and copper oxide in the solution. So then when that happens, then you will filter the mixture. So the insoluble copper 2 oxide will be captured, will be caught by the filter. Then you will get copper sulfate solution in the as a filtrate here. Then your crystallization start again. You see this process. Then you will heat the solution and then it becomes saturated. Then you take it out, put it out in the without the flame, and then you let it cool down and allow the crystals to crystallize. So the same steps turn out again. So this is if you add acid to insoluble base. Acid and insoluble carbonate is the same as acid and the base. So we can make use of the diagram here again. If it's a carbonate, if it's a carbonate, so what happened is you will use copper carbonate. Then the same steps will repeat again, copper carbonate with sulfuric acid, then you add excess and then you stir. Then you will end up having copper sulfate here and copper carbonate here. Then you will get copper sulfate again and then you repeat the crystallization process. That is for acid and carbonate. Acid and metal is also the same as this. So you just repeat this, but we cannot use copper anymore as an example because copper is an unreactive metal. So let's say I use iron metal. Iron reacts with sulfuric acid, then you form iron sulfate here. And then you filter, you will get iron powder here. Then the rest is the same again. The only difference is some exceptions here is that unreactive metals such as lead or copper and gold and silver does not react with dilute acids. Then super reactive metal like lithium, sodium, potassium, calcium cannot use also because it's very violent. Then you also cannot use this method to make insoluble salts such as lead chloride and lead sulfate and silver chloride. So this is the exception. Precipitation is used to prepare insoluble salts. And it's a bit more difficult to choose the reactants A and B. So this one, right, has to go back to, okay, recall again, that precipitation, you have to make use of this. So, precipitation, you have to make use of this. So you must first know in the metal ion the positive ion come from the base and the negative ion come from the acid. So you need to keep this in mind. Then we go back to precipitation. Okay, back to precipitation. So now to make something from precipitation method, first criteria, the thing must be insoluble. Then Second thing is you need to know how to choose your reactants. So the reactants you choose must be soluble in water. So you choose one reactant, one solution that contains the positive ion, and you choose another solution that contains the negative ion. And you pour the two of them together, then you will get the salt immediately. So in this case, the example, they prepare barium sulfate. So you must choose a solution, something something barium something. Barium something. Then plus sulfate, that means the acid that has the sulfate ion is sulfuric acid. And sulfate also can come from some other salts, like you can have solutions like sodium sulfate also contains sulfate ion. So you contain two solutions. So barium, a solution that has barium and then is soluble in water would be barium nitrate, because all nitrates are soluble in water. So this procedure, right, they use sodium sulfate and barium nitrate. So what they do is they pour the two solutions together. Then immediately barium sulfate is formed at the below, okay, at the bottom of the beaker. Then you stir until no more precipitate forms. Then you filter the mixture. So once you filter the mixture, now right, you collect the precipitate, because the salt is what the insoluble substance is the thing you want. So you collect the precipitate. Then you take the precipitate and then you wash it in water, distilled water, then you dry it. Then you get your barium sulfate already. So this is precipitation. So you must know these 5 methods. So we start with a flow chart again. So this flow chart is super duper important. Same as the solubility table of salts. So I would tell you how this works, this table works. So this summarize methods of preparation. So you have all your 5 methods here. So you start, the question will always give you some something that they want to produce. Let's say they want to produce copper sulfate. So using this flow chart, you will check whether copper sulfate is soluble in water or not.
It's soluble.
It's soluble. Okay, so if it's soluble, then this option cross out, so it'll be this 3. Okay. So then if it's this 3, then you will acid plus base. Copper sulfate, the acid will be sulfuric acid, plus base will be copper oxide or copper hydroxide. Can list out like that. Then acid, or you can use acid plus carbonate to produce copper sulfate. That means you get sulfuric acid and copper carbonate. Then last one, copper metal plus sulfuric acid. Is that possible? Is that possible?
It's possible.
It's possible.
It's possible.
It's not possible.
It's possible.
Not possible. Because copper is a non-reactive metal. Okay, so then the starting materials will be all this that I listed. You can choose either acid plus base or acid plus carbonate. So now you progress.
Acid plus carbonate.
So you progress. You progress, and then after that, these are the starting materials for the salt soluble in water. Yes or no?
Yes.
If you use copper carbonate is not soluble in water. You must check your solubility table. So copper carbonate is insoluble in water, so you cannot use titration. So, and you have chosen this method. Okay. You have chosen this method. So then if the question tells you, please describe the method to produce copper sulfate like this, with that method you decided. So you know it's an acid plus excess insoluble carbonate. So you will go back to your acid plus insoluble carbonate, describe the whole process for them using whatever their method, the description is provided here. That's how you do it.
Sulfuric acid in a beaker.
Yes, then add copper.
Then add copper carbonate
Until
no more can dissolve.
Yeah. Then
filter to remove the excess copper carbonate. Then collect the filtrate.
Which is copper sulfate.
Then concentrate, crystallize, and filter.
Yes. Then you get copper sulfate crystal.
Copper sulfate.
Then you get copper sulfate. Okay, back to this. I'm gonna erase and then explain another one. How do I erase this? Eraser. I saw eraser option. Erase all the ink on slide. Okay. Okay, back to this. So let's say now I want to get ammonium sulfate. I want to prepare ammonium sulfate. Okay, so you tell me about it.
2SO4 plus ammonium hydroxide.
So okay, first obstacle is the salt prepared to be prepared soluble in water. Yes, no. Yes. So here no. Okay, so you will use, you were saying ammonium what?
H2SO4 plus NH4OH.
Okay. So you can also use ammonium hydroxide plus what? Can I? No. Bye. Ammonium carbonate. Use ammonium carbonate plus sulfuric acid. Then no metal here, so bye. Then down to the next obstacle are the starting materials for the salt, soluble or insoluble.
Soluble.
Okay, so it's soluble, so you don't use this. So you auto transfer this to here. Then How? So you know it's titration. So then you go to your titration process. Describe titration. So you just take the whole answer from here, change the reactor names. Then you'll be okay. Okay. So last example. Last example. I want to prepare silver chloride. Tell me about it.
Silver hydroxide plus hydrochloric acid.
You have to check this first. Is it soluble in water?
Yes.
Silver chloride soluble in water.
No.
Okay, so it's this side no more. So this whole branch is gone. So you need precipitation. So you know precipitation in front comes from something, behind comes from another solution. So what can I use here and what can I use
The
here?
behind comes from hydrochloric acid.
Okay, then in front.
Silver hydroxide.
You remember these two must be soluble in water. Silver hydroxide is not soluble in water.
Silver carbonate.
Silver carbonate is also not soluble in water. Check your solubility table. You need a solution related to silver that is soluble. That you need a solution that is
Silver sulfate.
silver sulfate soluble in water. Is it so? Okay. Most sulfates are soluble except for calcium, barium, and lead. So silver sulfate is soluble. Okay, pass. So we'll go back. Silver sulfate. Then what's next? So you have these two. Then you go back to the precipitation method here. So you will have silver sulfate and hydrochloric acid. Then you pour them together. Then you stir until no more precipitate forms. Then you filter the mixture, collect the silver chloride. Then allow the precipitate to dry between a piece of filter paper. Then you wash the precipitate. Oh, no, you wash the precipitate first, then you dry it on filter paper. Something like that. So you can fill up the blanks. Silver, like that. Okay. That's sulfate. Okay. Next. What is the name of this technique? Next one. State the type of salt, soluble or insoluble, prepared by this method. Soluble. Okay, now this is an explanation question. So you have to explain why this technique is the most suitable to prepare this salt. I would suggest you write something that you think you will hand up for a test paper. So write in that manner. Why is it most suitable? Both reactants are aqueous and the product is soluble. So reactants are aqueous, then you need the exact amount of alkali. to neutralize the fixed volume of acid because the excess reactant cannot be removed easily. So you have to mention this part. Because if it cannot be removed, then you will use this. If it can be removed easily, then you will not be using titration anymore. So you only got, like, say, half the answer. Okay, why is it this? Okay, typo down here. That is Burette. Spelling mistake.
One.
Yeah, what he put. This one? Name a suitable indicator. I have one indicator in mind, but I think another one will work too. What is a suitable indicator? Yeah, okay. Phenolphthalein works too. Describe and explain the importance of using indicator Y in this preparation of salt. Describe and explain. So it would be a relatively long answer. So write something. It is important to know the exact amount of NaOH that has completely reacted with acid. So what does indicator Y do?
Indicate what kind
Indicator.
what kind of the react the product is, what acid the what salt the product is.
Indicator Y tells you when neutralization takes place. So what happens? So when neutralization takes place, the mixture will only have the salt, and there will not be any sodium hydroxide, and there will not be any HCl. So when you use indicator Y, you know the point where neutralization takes place, and you can identify the amount of sodium hydroxide and amount of HCl to use accurately. So you have your indicator. Now your answer will be a bit different. So you can say that so you have the metal orange change color, right? So you can say that metal orange is whatever color before and whatever other color after. So because it's important to know the exact amount of NaOH that reacts completely with HCl. So the titration will stop when metal orange change to another color. So you can avoid excess amount of blah 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 sodium hydroxide being added into the thing, into the acid. So you can just change your answer in that way. But all in all, it's just you have to indicate that it will tell you, the change in color will tell you the amount of, the change in color will tell you when neutralization takes place, and it will tell you the amount of sodium hydroxide to use to react with a certain amount of HCl. Okay, then you have one question like this: explain why universal indicator is not used as indicator Y. It's a variety color, so it's yeah. Lithium nitrate is a salt that can be prepared by reacting an acid with alkali, whatever you call it. Suggest the suitable reactant. So what acid to use, what base to use? Lithium hydroxide and nitric acid. Okay. Name the method for this salt preparation. And both reactants are equal solution then, and some more.
And the product is soluble.
Another question with drawing. Yeah. Next. What is solution X? Water. Why water?
Because it's an acid, we are some base.
So your
And then sulfuric acid, we have copper 2 hydroxide.
So the copper 2 hydroxide is the black color substance. The copper 2 hydroxide is this. Then you say add to sulfuric acid. That means this one must be sulfuric acid. Yeah.
I thought the solution X is the residue.
Then solution X, you filter, then the residue will be the copper hydroxide because this is not soluble. Then the filtrate will come out as copper sulfate because all the acid has been used up. You have what they do is they take a lot of copper hydroxide, throw into sulfuric acid. So when there's sulfuric acid, the copper hydroxide will dissolve. Then you keep pouring in copper hydroxide, then the sulfuric acid will be used up. So when it's used up, right, then it will not dissolve copper hydroxide anymore. So then you will filter. When you filter, right, whatever you filter, the filtrate will be copper sulfate. Then the residue will be copper hydroxide. There will not be any sulfuric acid left because all has been reacted by copper hydroxide. So it's sulfuric acid. So because the reason why you use sulfuric acid because you want sulfate salt. Sulfate salt can only be obtained from sulfuric acid. Part C, a solid substance is added to in excess to solution X. When solid substance is left in the solution, it is filtered and forms a residue on filter paper. So you're supposed to name two possible solid substances that forms the residue on the filter paper. So just now you mentioned copper hydroxide. Copper hydroxide is one that you can use. What else can you use? Anything else?
They say 2 possible.
Yeah, you can have another copper carbonate. Then see part 2, explain your answer. Why you use copper hydroxide and why you use copper oxide. You can write down your answer while I go and pick up something. Okay, both react with sulfuric acid to form copper sulfate. Okay. Next one. Okay. So you have to explain why solid substance is added in excess. I kind of gave the answer just now. So as to make sure that all the acid is used up. Filter the solution. Okay. Heating the solution until saturated. To allow crystallization of copper sulfate easily. Okay. Okay, this write a balanced chemical equation So you start with your word equation, then your balanced chemical equation. I want to see the working. My answer got typo. Yeah, so you have to describe this. I'll leave this to next time.